Okay, so this is the quick review series. So these are extra practice problems from the linear equations review. So mostly there's going to be fractions and decimals, but also just a couple of harder ones to get us warmed up. So these first two don't have fractions and decimals, but I think they're a little harder. And then the rest of these are all fractions and decimals. So you can pause if you want to read these over. So this video specifically continues extra practice exercises that accompany a review video on the same topic. So if you want to see the review of like how to approach these problems at a slower pace, check the description for a link to that review video. Also, you can get a free PDF version of all those problems with an answer key at divideandconquermath.com. Just go to the review section. You can download all of that for free. Okay, so like I said, these are the problems that I'm going to go through in this video. So if you want to pause this and work through them, go for it. So remember, math is not a spectator sport. If you're trying to get better at this, I think it's better for you to try one and get it wrong and then see how to do it versus just watching someone on YouTube do it correctly every single time. Okay, so let's get into this. So for this first one, the first thing that I've got to do is I'm going to have to distribute. So I'm going to go ahead and just distribute. So this is 4x. You know what? I'm actually going to take the minus 6 plus 5. I'm going to write that as minus 1. And then I'll distribute on this side. So this is 10x plus 5 minus 6x plus 7. And so now on this side, I'm going to collect my like terms. So I'm going to have 4x minus 1 equals 4x plus 12. And then if I subtract off the 4x's, I get negative 1 equals 12. Now you may have taken a slightly different route to get here, and you may have, I talked about this in the review video, but you may have a slightly different answer. But at the end of the day, what does this mean? These are two non-equivalent numbers, right? And we have an equal sign here. So this answer is nonsense. So what that means is that there is no solution for the solution. And we can put the empty set there if we would like. Okay, so moving on to B here. So now I have quite a few things to distribute for this one. So I'm going to go ahead and just start distributing. So this is 6x plus 12 minus 10x plus 8 equals 12x minus 8 plus 12. Okay, so now we just need to collect like terms on each side. So on the left side, I've got the 6x minus the 10x, so that's minus 4x, and then the 12 plus the 8, that's going to give me 20. And on the other side, so I've got 12x, and then negative 8 plus 12 will give me plus 4. Oops, and I dropped my x, didn't I? Okay, 12x plus 4. Cool. So now I just need to collect all my numbers to one side and all my letters to another. So I'm going to bring the 4x over to this side. I just like trying to keep things positive. I'm a positive person, you know what I mean? Okay, so now this is going to be 20 equals 16x plus 4, and then I'll subtract off the 4. So now I have 16x equals 16. So if I divide both sides by 16, I will get that x equals 1. Okay, so now we get to the fun stuff with working through decimal and fraction problems. So I talked about working with decimals at length in my other video, so feel free to go back and check that out if you want more problems and explanation with that. But so what I'm going to do for this one, right, is so I'm going to count the maximum number of decimal spots. So we've got 1, 1, and then 2 here. So since 2 is the maximum number of decimal spots, I need to move all of these decimals over 2. And the other thing that we talked about in the review video, right, is that for a cluster like this, I only do it to the decimal. So this is a term, this is a term, and this is a term. And again, I broke more of that down in the review video, but I've only got 3 terms, so I'm only going to do that 3 times. I don't need to do it inside the parenthesis. So what is this going to become? This is going to become 20 times 3x minus 1 plus, oops, and I missed that here, plus, so this is going to turn into 180 equals 55 times 2x plus 4. Okay, so let's get to distributing. So this is going to become 60x minus 20 plus 180 equals 110x plus 220. Okay, cool. And so now we have to collect some like terms. So let's see, this is going to turn into 60x plus 160, and then this equals 110x plus 220. Okay, so now I got to bring stuff to each side. So let's see, I'll subtract off the 60x here. So I have 160 equals, what is that? That's 50x plus 220. So now I can subtract off that 220. And so 160 minus 220 is going to equal negative 60. Oops, sorry, my thing just went out of focus. There we go. Okay, so this will be 50x equals negative 60. Okay, so now we just need to discuss this. So let me actually make a little space. Okay, so I'm going to divide both sides by 50, and clearly since these both end in 0, we can divide the top and bottom here by 10, so this will equal negative 6 over 5. Now, depending on the answer format, this could be acceptable, but it is possible that you would have to return an answer in a decimal, so I just want to talk about how would you figure that out from here. So I need to divide 5 into 6. So 5 goes into 6 once, right? So I can subtract off that 5 and I have a remainder of 1. So what do I do with this remainder of 1? Well, now we can get into a decimal here. So what I can do is I can add this decimal, this 0.0, bring this 0 down. How many times does 5 go into 10? It goes in twice. So I need to transfer that decimal here, and then 5 goes in twice. So the alternative to this would be negative 1.2. So it just depends on the answer format that you need, but I just wanted to make sure that I went through how to do both. Okay, cool. So let's keep going. So we're now going to work with fractions. So I talked about in the previous video that what we need to do with something like this is we need to find the LCD of all fractions. And so the LCD of all fractions in this case will be 30. So I need to multiply every single part of this problem, each term, by 30. So I'm going to set that up. Okay, so I set this up. There's a lot I had to cram into this, but hopefully you can kind of make it all out. So I want to just point out, so in terms of terms, I have this term, this term, this term, and this term. So we talked about this also in the previous video. So I have 4 terms. So I need to multiply that 30 1, 2, 3, 4 times. And now that I've multiplied by the LCD, this is going to cancel out the fractions. So 30 times 1/3 is just 10. So the thing in front of this set of fractions just becomes 10. And so then this is 3x minus 5. Now, remember, there's 2 ways that you can do this. You can either think of this as just 30 times 1/3 if that's easier to you, or if that kind of trips you up, you can say, how many times does 3 go into 30? That's 10 times, and then you can take 10 times 1. Okay, so continuing on, so now I've got 30 times 2/5. So again, you can either do 30 times 2/5, or you can ask yourself, how many times does 5 go into 30? So 5 goes into 30 6 times. And what is 6 times 2? 6 times 2 is 12. So I can rewrite this as minus 12 times x minus 2. So alternatively, 30 times 2/5 is 12. So it doesn't matter which way you want to think about it. What about 30 times 1/6? So 30, that's really 30 divided by 6. So this is going to be 5. Let's see. It's 2x minus 1. And then finally, 30 times 2/3. So what is 2/3 of 30? Or I'll show it to you one more time. 3 goes into 30 10 times, and 10 times 2 is 20. Okay. So here is what I'm left with. So this is still quite a bit of work, so let's make some space. Okay, and now we can just push forward with this. So I can distribute, so this becomes 30x minus 50 minus 12x plus 24 equals 10x minus 5 minus 20. Okay, so now I got to collect my like terms. So on the left side, this is going to be 18x minus 26. And on the right side, this will be 10x minus 25. Okay, cool. So now I need to bring everything over to one side. So I'm going to subtract off the 10x. So now I've got 8x minus 26 equals negative 25. And then I can add the 26 to both sides. So I have 8x equals 1. So if I divide both sides by 8, I get that x equals 1/8. And since this one started with fractions, I'd say that that would be an okay way to leave the answer in this case. Okay, so here we have another decimal problem. So hopefully you've given this one a try. So for this one, I'm going to need to move all of the decimals over one place. Now the tricky thing with this one is that you also need to move the decimal with the 3. There's that invisible decimal right here, so I need to move that over 1. So that could be, if you're watching this because you got it wrong from the practice sheet, that could be why. Okay, so if I rewrite this now, I've got 12 times x plus 4 minus 5 equals 30 times x minus 1 plus 9x. Okay, so now we're just going to go and distribute all this goodness. So this is 12x plus 48 minus 5 equals 30x minus 30 plus 9x. And then we can collect our like terms. So this will become 12x plus 43 equals 39x minus 30. Okay, so from here, let's see, I think I'm going to run out of room, so I'm just going to do this all in one step. So I'm going to subtract the 12x's to one side and bring the numbers over to another. So this is going to turn into 27x equals 73. Okay, so now when I divide both sides by 27, so now we've got to kind of make a decision here. So I'll make a little space. So I do just want to talk about different answer formats. So if you're allowed to keep things as an improper fraction, then this would be your answer. Now, in the event that you need to write this as either a mixed number or a decimal, let's just go through that calculation real quick too. So I'm going to have 27 goes into 73 2 times, okay? So you might have to do a little math to figure out what is 2 times 27, and that's okay. But 2 times 27 is 54. And so if I were to subtract this, so let's see, I can, borrow from here. So 13 minus 4 is 9, 6 minus 5 is 1, so this is going to be 19. So one answer format here would be that this is the mixed number 2 and 19 over 27. Or if we have to do this as a decimal, we can continue this calculation. So what I'm going to do is I'm going to put a decimal here, so the rest of this will be decimals. So let me make a little space here with this subtraction that I did. Okay, so then what I'm going to do, I'm going to put a decimal here. I'm going to ignore the decimal, and now I'm going to bring down the 0. So how many times does 27 go into 190? Which is, I think, kind of a tough thing. That might be something where you have to sit down and actually just like play around with doing some annoying like calculations. Like if you don't know off the top of your head, you might have to experiment with it. But just to keep this video short, I will tell you it goes in 7 times. So 27 times 7 is 189. So that leaves me with a remainder of 1. And so then, is this a good enough decimal? Well, it just depends. So then I could go ahead and add in another 0, bring that down. How many times does 27 go into 10? That would be 0 times. So then I'm going to add another 0. How many times does 27 go into 100? That would be 3 times. And you could just continue on this calculation for as long as you need. So just a quick review if you need that. And for the final one, okay, so for this last one, so like I said, I just plow through all of these. You've got the problems at the beginning. So I need to figure out what the LCD is. The LCD in this case is 6. So I'm going to multiply everything by 6. So I'll just show you what that looks like. Okay, so here is 6 times each different term. So just to show you the different terms, we have this term, this term, this term, and this term, okay? So I've multiplied it 4 times. Okay, so now I've got to do the multiplication. So 6 times 1/2 is just 3. And then 6 times 1/6 is just 1. 6 times 1/3 is 2. And then 6 times 2/3. So again, if you're not sure if that messes you up, you can always say 3 goes into 6 twice, and then 2 times 2 is 4. Or 2/3 times 6 is 4, whichever you prefer to think of it as. And okay, so now I can go ahead and distribute. So this will be 3 minus x plus 5. Make sure you got that as a plus 5. That's a really common error. This will be 2x plus 2 plus 4. If I collect my like terms, this becomes negative x plus 8 equals 2x plus 6. So I'm running out of space here, so I'll go ahead and add x to each side, and I'll subtract the 6 from each side. So now I have 3x equals 2, and if I divide both sides by 3, I have x equals 2/3 for this one. Okay, and so for our final one, so I have this problem here. So it's the same idea, right? So what is the LCD? So my LCD in this case is 9. So I'm going to multiply everything by 9, so I'll just show you what that is. So here's me multiplying 9 by each term, just to show you the terms. Here's 1 term, 2 terms, and 3 terms. Okay, so 9 times 1/3 is going to be 3. 9 times 4/3. So again, if that throws you off, you can say, how many times does 3 go into 9? 3 goes into 9 3 times, and 3 times 4 is 12. And then in this one, these 9s cancel out, so I'm just left with -5. Okay, and so from here, I can distribute. So this is 6x plus 3 minus 12 equals -5. And so then let's see, I get 6x minus 9 equals -5. Add the 9 to each side. So I get 6x equals 4. Divide both sides by 6, and x will equal 2/3. Okay, and so we are going to leave it at that. Just as a reminder, so my review series has many other topics in it. So this was a little series on linear equations. Each topic has the refresher video, practice problems and the answer key, and then video solutions if you don't understand the answer key. So you can get all these materials at divideandconquermath.com. Just go to the review section and you'll find everything there. Okay, guys, so I hope this was helpful. I'll talk to you next time.